Welcome to this explainer. You know, it's wild to think about, but premature corrosion from misspecified cable trays literally costs industrial projects millions of dollars every single year. So today, we're going to build a clear, actionable decision-making framework specifically for procurement teams and engineers. Galvanized steel is one of the most common choices out there, but surprisingly, it's also one of the most frequently misspecified. Well, we're going to fix that right now.
Look, we've got to address the elephant in the room right off the bat. A massive red flag for any procurement process is ordering just by a basic finish name, or checking the sheet thickness without actually verifying the surrounding environment. It's a complete specification trap. I mean, it looks perfectly fine on a spreadsheet, but in the real world, that is exactly where severe project problems begin.
To stop these costly mistakes, we're going to follow a quick roadmap: the specification trap, pre-galvanized versus hot dip, choosing the tray form, 4 essential engineering checks, and finally, the ZINMA standard. This is going to give you the ultimate filter for your technical data. Okay, Section 1, the specification trap. Let's see why those basic specs just aren't cutting it.
You see this all the time, and it perfectly illustrates why relying on basic catalog names leads to failure. Procurement teams often grab a finish name or sheet thickness off a spreadsheet and call it a day simply because the numbers align. But there is a huge disconnect between the buying office and the actual engineering site. If you're ignoring the real corrosion class, the load span, or the physical form of the tray, you are literally gambling with the integrity of the entire cable management system.
Moving right along to Section 2, pre-galvanized versus hot dip. This is the core engineering trade-off.
This right here is the absolute focus for you procurement folks. You aren't just comparing two products, you're comparing two entirely different survival profiles. See, pre-galvanized sheets are cut and punched during manufacturing. And what does that do? It leaves those raw steel edges completely exposed. If you try to save a few bucks by throwing that into a wet environment, you are looking at a total system disaster down the line. It's all about matching the precise chemical protection to the physical reality of the site. So let's map this out clearly. Pre-galvanized steel, that belongs strictly indoors. Think dry, climate-controlled data centers or clean commercial spaces. But if your facility has washdown-prone areas, or you're routing cables outdoors in industrial conditions, hot-dip galvanized is your absolute must-have shield. Because it goes into the zinc bath after fabrication, it gets a much thicker coating that seals every single cut and hole. It actually survives those harsh realities.
All right, Section 3, choosing the tray form. Because the finish, that's really only half the battle.
Procurement teams have to evaluate the actual physical architecture, ladder, perforated, or solid bottom, and notice how their performance profiles vary wildly. For instance, a ladder tray gives you maximum airflow for high heat cables. That completely changes your thermal math compared to a closed system. On the flip side, a solid bottom tray sacrifices that airflow, but it gives you maximum physical protection from falling debris. You've got to align the form perfectly with the weight and heat of the specific cables you're running.
Which brings us to the climax of our analysis. Section 4, 4 essential engineering checks. Consider this your ultimate procurement checklist.
Before you even think about signing that purchase order, you have to run these 4 mandatory checks. Step 1, verify the corrosion environment so you know exactly what finish you need. Step 2, run your load and span numbers so the tray doesn't sag under heavy cables. Step 3, verify the electrical bonding for a safe grounding path. And Step 4, check your cable fill for actual physical capacity. Honestly, skip any of these steps and your project is completely at risk.
Finally, Section 5, the ZINMA standard. Let's look at a real-world case study from the sources that perfectly aligns with these rigorous engineering checks.
The sources highlight Shinma, a manufacturer based in Shanghai, as a prime example of an operation implementing these frameworks correctly. They build comprehensive solutions, stuff like cable tray systems, busways, seismic bracing, and intelligent cable management. And because they're supplying highly demanding infrastructure sectors like data centers, rail transit, massive industrial plants, and commercial buildings, they really have to deeply understand the extreme variations in those environments.
And here's the thing. For any manufacturer's products to be considered a true gold standard by a procurement team, strict compliance with international and domestic safety standards is just non-negotiable. Whether we're talking IEC 61537, NEMA VE1, British standards like EN 50085, or Chinese GB 31251 standards. Hitting these targets is what validates that those 4 engineering checks we just went over have actually been rigorously tested by the manufacturer.
So I'm going to leave you with this one critical question to evaluate your own procurement habits. Are your current cable tray specs genuinely matched to their real-world environment?
The next time you're reviewing a quote, ask yourself, are you just buying a catalog number or are you buying a calculated engineering solution? Keep these frameworks in mind, use those essential checks, and make sure your next build is truly meant to survive.